Hello and welcome to part 3 of my DIY ukulele kit video. I put links to parts 1 and 2 in the description. While the paint is drying, we're gonna get deeper into the FX selector. This green wire is the signal from the microphone, which will send to the LM386 board used as a distortion stage, or this PT-2399 echo delay board, or both of them. Or we send the dry signal directly to the output jack. This will be done using a rotary selector, and here is how it works. This selector has 3 inner legs and 12 outer legs. Those legs are labeled 1 to 12, but for a better understanding, we will use 1 to 4 3 times. Because this is indeed a group of 3 identical selectors linked to each other. Well, let me explain it better. When the knob is in the first position, all 3 inner legs are connected to their own first outer leg. But the outer legs are not connected, they are not linked to each other. When we switch to the second position, each inner leg is connected to the second outer leg. And it's the same for third and fourth position. Let's draw the selector in a different way. Here is the inner leg, and there are the 4 dedicated outer legs. We have a second and a third one. I built a model of that selector to show you better. This black lever selects which legs is to be connected, like the knob on the actual selector. Now we have our main output, the jack socket of the guitar, the delay board with its own input where we will send the signal to be processed, and its own output. Then the distortion board, also with an input and an output. The blue pins on the left represent the inner legs of the selector. The first one, A, will receive the direct signal from the mic. The B leg will be connected to the delay's output, and the last one, C, gets the distortion board's output. For clarity, I won't draw those connections, only the corresponding letters. Now, I want different configurations, like we've seen in the previous video. So 1, the signal through the delay, 2, through the distortion, 3, going into distortion and then distort the signal into the delay, 4, going both to delay and distortion in parallel. That means the clear signal goes to the delay and a copy of this clean signal goes through the distortion. The effects, they don't interact with each other. Let's draw the wiring now. First position, only delay, so let's connect the input of the inner leg A, the one connected to the mic, to the input of the delay board. And then the output of the delay board, which remember is connected to inner leg B, is connected to the output jack. Very good so far. Output of the distortion board isn't connected to anything. Now, the signal to go only through distortion. So we select the next position, and as you can see, each inner leg is now connected to its outer leg number 2. So the signal, still coming from A, goes to distortion board's input, and the output of the distortion, which goes to inner leg C, has to be connected to the output jack. But no need to connect another wire all the way to the jack. Instead, let's connect leg C2 to leg B1, which is already connected to the output. When in first position, the B1 leg will be connected to C2 leg. But since this C2 is connected to nothing in this case, that won't be a problem. So we check the mic signal is connected to the distortion, and the distortion signal goes to the output jack. Perfect. For the third position, signal has to go through the distortion and then through the delay. So same process. A3 has to be connected to the input of the distortion, but let's connect it directly to leg A2 since it is already connected to distortion, but distortion signal has to feed the delay now. So leg 3 is connected to delay in. But once again, it is shorter to connect it to A1, which already has a wire going to delay in. See, all legs are grouped there, and believe me, the less wire you have, the less mess you get. And anyway, when it's in another position, we don't mind the other connections since they're not linked to anything. Back to position 4, where the signal feeds the 2 effect boards in parallel. A4 goes to distortion, so we connect it to A3, but it also has to go to the delay, so we connect it to A1, and we will send the delay out to... Oh, I realized I forgot a connection in position 3. Delay output needs to be sent to jack socket, so Let's do that and connect B3 directly to B1 and we're set. And since in position 4 delay also goes to output, let's connect it to B3. Also, don't forget that distortion in this case also has to go to the main output, so let's connect C4 to C2, which as you can see is connected to the output as well. Now we have more connections made, so we need to check if the signal isn't going where it's not supposed to, and for that we need a diode, which kind of works like a one-way switch. It allows current to flow in one direction but not the other way around. It's kind of it. It's more like severely restricted, and that will do for my projects, I guess. Final check. Position 1, signal going to delay but also to A4, A3, A2 and distortion that we do not want. So let's implement a diode right here, so signal cannot go from A1 to distortion but will flow from A4 to delay. B1 to output, okay. B3 and 4 not connected. C2 and 4 same, okay. Position 2, A2 to distortion, okay. A3, A4, alright, but also going to delay, which is not what we want. So we put a diode there between A2 and A3, so no signal can come from A2. C2 goes to C4 and B1, 3, 4, not connected, okay, but also goes to output, which is supposed to, so alright. Position 3 to distortion and then to delay, so A3 from the mic is going to distortion, okay, and into the delay. Oh, I made a mistake. This diode here should move to there. It's weird, I didn't notice that at first, but okay. I kind of correct it. From the delay, B3 goes to B4, which is not connected, like C2 and C4, but it goes to the output. Okay, correct. B3 coming from the distortion goes into the delay and cannot go to A4 thanks to the diode. Perfect. Position 4 to distortion and delay in parallel. So A4 going to delay, okay, going to distortion, right. B4 from the delay is going out, okay, and also going to C2 and C4. The distortion output, no, okay. Let's get some help from a diode once again. Signal can't go that way, great. Now C4 going to output, okay, and oh, no, not to leg B4, so let's implement a last diode there, right? No, the other way around, otherwise it's useless. Here will be even better. Well, it's all checked out, so let's connect everything in real life and test if what I imagined is working correctly.